Welcome to Easy Maths. In this lesson, we're going to focus our attention on the concept of compound interest. And let's just turn there. Now, normally, compound interest involves cases where the interest that has been earned after every compounding period is added, or we say compounded, to the principal. And this will normally increase the interest that is earned at the end of the compounding period. Now, this compounding can happen annually, semi-annually, monthly, quarterly, or some duration as per a given institution, that is a bank. Now, the amount that we get at the end of the compounding period will be the compound interest plus the deposit. That's our principal. Let's look at an example. We're told, find the compound interest accrued if 8,000 is invested at 13% per annum for 3 years. Now, the interest that is earned in the first year will be simply gotten using the simple interest formula. That is 8,000 times 13 over 100 times 1, which is 1,040. But the principal of the second year will be the interest that was earned at the end of the compounding period, the first compounding period, that's the first year, plus the deposit we had. That means the interest that we earned plus the deposit we had, that it was our principal, gives us the principal of the next year, and that's the compounding aspect. So the compounding, so that the principal of the second year will be 8,000 plus 1,040, which is 9,040. And therefore, if now we want the interest for the second year, will be 9040 times 13 over 100 times 1, which gives us 1,175 and 2 cents, 20 cents rather. Now, the third year, the principal will therefore be 9,040 plus 1172.2, 11.75.2, which gives us 10,215.2. Please notice that this is now the principal for the third year. Therefore, the interest will be 10,215.2 times 13 over 100 times 1, which gives us 1327.976. And therefore, the total interest will be the 1040 plus 1175.2 plus 1327.976, which gives us 3,543.176. Now, this process is very lengthy, and therefore we have an alternative method. This step-by-step can be very lengthy, especially if the compounding periods are many, say 10 years or so. Now we have the formula for compound interest, which normally reads A is equals to P in brackets 1 plus R all over 100 raised to the power n, where A is accumulated amount. I said that at the beginning. That's a principal plus the compound interest. Then principal, we know the amount that the person deposits at the bank. The rate is the rate of interest that's used by that bank for compound interest, and n is the compounding times. Now, in our case, the principal is 8,000, R is 13, and n is 3, and therefore putting the values in the formula, we get 11,543.176 is the accumulated amount, and therefore the interest is actually this figure minus the deposit, which was our principal, and in our case is going to be 3,543.176 shillings. And please notice that this figure is the same as this. That tells us something. Whenever we are calculating compound interest, we can always use the formula A is equals to P in brackets 1 plus R over 100 raised to the power n to get us the accumulated amount. If we subtract the principal from that accumulated amount, we get our compound interest, like we done in this particular case. Maybe now we turn to other examples, and before that I need to say something. If the rate of interest is R% per annum and is compounded n times per year, then the rate per period is simply R divided by n. And if the compounding period will be n times the number of years. Let's see what I mean there. Find the compound interest earned if 110,000 is invested for 5 years at 14% per annum, compounded semi-annually. Please notice that principal is 110, rate is 14 over 2. Why? We have 14% per annum, compounded semi-annually. It means it's compounded it's calculated at 7% in the first half of the year and 7% in the second half. So that 2 7s gives us a 14. That's why R is actually 14 divided by 2. The 2 is the number of halves in a year. Now the n will be 5 times 2. The reason is we have 5 years, but every year has 2 halves. So we have 10 halves, 10 half years, 10 compounding periods. Putting the formula values in the formula, we get this sort of thing. Please continue, simplify that. Using your calculator, you get your answer to be this amount here, but the interest will be 216,386.6 minus 110,000, which gives us 101,386.6 shillings. Sorry. Another question told, find the accumulated amount if 15,000 is invested for 2 years at 12% per annum compounded quarterly. In this time, principal is 15,000, the rate is 12 over 4. The reason is it's compounded quarterly. It means we have 4 quarters a year, and since we have 4 quarters, it means the rate per quarter will be 12 divided by 4, which gives us 3. The n will be 2 times 4 because we have 4 quarters in a year. 2 years would have 2 times 4, 8. That means 8 compounding periods, and therefore, putting the values in the formula, we're going to get what you have here, and then you simplify that, get 19,001.6 shillings. Now, moving on to the last question, we have find the time taken for 50,000 to grow to an accumulated amount of 71,105 at a rate of interest of 18% per annum, and it's a compounded quarterly. Now, please notice that in this case, the amount is given, the principal is given, the rate is given, is 18 over 4. The reason is it is 18 per annum and is compounded quarterly. We get 18 divided by 4 to get the rate. Because we have 4 quarters, it means that 18, we have 18 divided by 4 rate every quarter. The n we are also not given. We're not given that. So we approach this question slightly in a different way. And this is what we do. Since what you're not given is n, putting these values in the formula that we have been having at the beginning and all the way, we get this sort of a thing. But to get the value of n, which is what we are asked, because we told find the time taken, we're going to divide first of all both sides by 50,000. We get this sort of a thing. 31,105 divided by 50,000 will give us 1.4221 is equals to what we have after the equal sign. Since the 50,000 will go away, at this point we introduce logarithms. So we have log of this is equals to log of this. And again, bringing the n before the logarithm, we get n log 1.045 is equals to that. And therefore, n will simply be the log of 1.4221 divided by the log of 1.045, which in our case is 8. It is 8 compounding periods. But the question was, how long? Maybe the answer should be given in years. We said in the previous case that the compounding period will be n times the number of years. So this 8 is the number of quarters, that is 4 times some number. And therefore, what is that number? We're going to get 8, you divide by 4 to get the number of years, which is 2. That means 2 times 4 would give us the number of compounding period, which is 8. And that brings me to the end of this second lesson on compound interest. But check out for more videos coming shortly. Thank you.